Thanks for inviting me here. And I'm going to sort of talk about, where my attitudes towards open source came from, because they started pretty early. I'm not exactly sure how old I am in that picture. My mother insists I'm 14. I think I might have been a year or two older. That is one of the ground station computer rooms of the ISIS-2 satellite, and I got hired as a hacker, believe it or not, mostly because I had taught myself how to code. The problem with learning to code then was that all there were like really basic books, and finding anybody who knew how to code was almost impossible. And I just viewed it as the world's craziest puzzle. And nonetheless, I persevered, but I had some really interesting events along the way. So one of the first for me that was clearly open source was this one. The guy over here, this is a picture of Nicholas Wirth in about 1970, roughly the time that he created the Pascal programming language. And one of the things that he did was he sent mag tapes to kind of anybody who asked for. And the place where I was working, the University of Calgary, got one of these tapes. And the tape had two things on it. One was a binary of the Pascal compiler, and the other was the source of the Pascal compiler. And of course, the source of the Pascal compiler was exactly one file. The Pascal, because Pascal allows procedures within procedures, it was literally one function. But it was really quite amazing to learn from. I mean, this was the first time I had ever seen a full-up, large-scale piece of software written by somebody who actually knew what they were doing. When I was working in the physics department, it was mostly physicists and electrical engineers. And they're all smart people, but they're smart at whatever it is their specialty is. Learning programming from somebody whose specialty is the particle physics of the upper atmosphere and the interactions of like alpha particles in the magnetosphere, it's entertaining, but you don't get the best skills, right? And this piece of code from Wirth, which, if you look back on it, it was a pretty simplistic compiler, but it was that simplicity made it extremely comprehensible. And so it was this thing that I could edit. I had a couple of friends who were kind of partners in crime in messing around with the Pascal compiler. At one point, I actually got hired to port it to Multics. I don't know if anybody here remembers Multics. But Multics was a fabulous operating system destroyed by corporate stupidity. If Multics had been open source and not handled by clowns, Linux wouldn't have happened. And Unix wouldn't have happened. Because the people who started Unix had actually been on the Multics project, and Unix in many ways was their reaction to Multics having gotten kind of out of control. But it was a really important formative experience for me to actually be able to dig my hands into this compiler. The next one along the road for me was Simula. Does anybody here remember Simula? No. And so Simula was the world's first object-oriented programming language, predated Smalltalk by 10 or 15 years. And it came from the Oljan Dahl and Kirsten Nygaard at the Norwegian Defense Research Institute, or Research Establishment. And you know, we got a copy of that, but it was a binary and the source, but the source wasn't on the tape. The source was printed out on a stack of paper about 8 inches thick. And it was written in CDC 6000 assembler. And for some sadistic reason, I read it. And this thing over on the right-hand side, this is an example of what CDC 6000 assembly code looks like. And it was, you know, a pretty horrific way to handle it. And at one point, I got a part-time job to make it interact better with the I/O system on the rather grotesquely patched OS that we were running it on. But since I had the binary and the printout of the source, all I could do is binary patching. And you folks have probably never done binary patching of code, but it sucks. That's a technical term. But in sort of using Simula, I really fell in love with object-oriented programming, and I really fell in love with coroutines. And then on the other hand, having the source code with me, I could actually learn how it all worked. You know, what was the magic underneath coroutines? What was the, you know, what was the implementation trick that made object-oriented work? You know, what was a virtual function table and how does it really work? Because people would never really document that kind of stuff. Even in the first PhD thesis, the first place that there's like a piece of code that's clearly object-oriented, it was a piece of assembler written in TX2 assembly language on at Lincoln Labs by Ivan Sutherland. And if you ever want to have your socks blown off, just read Ivan Sutherland's thesis. He spends like a paragraph describing object-oriented programming, and he spends like half of a chapter on doubly linked lists, because he thought doubly linked lists were way cooler than object-oriented programming. And you know, eventually, when I got to doing my PhD thesis was essentially a macro expansion of 1/2 of one paragraph of Ivan's thesis. And having had the privilege of having Ivan on my thesis committee, it's just like, it's just amazing when you really read from someone who's worked at that kind of level. Then eventually I got to Carnegie Mellon. And Carnegie Mellon was, and still is, a pretty amazing place. And one of the things that was kind of in the air, even though I got there kind of after the fact, and since I wasn't actually there at the time, I just sort of witnessed the after effects in the culture of the place. Not entirely sure that I got all the details right, but so I don't know if any of you have ever listened to the rock opera Godspell. That was actually a project that one of the students did while he was a student at Carnegie. Carnegie Mellon has really 2 world-class departments: computer science and performing arts. And so this person writes Godspell, he graduates, Godspell becomes a big deal on Broadway, makes gobs of money, the guy becomes famous. CMU had interesting intellectual property laws with respect to students, namely that whatever students did, students owned. A lot of other universities, and I suspect most other universities, have these rules that essentially say that the student gets, like, it's some split, like 50-50, that the school gets and the student gets. And so what CMU tried to do was retroactively change their IP rules. And that did not go over well. And exactly what happened, what court cases happened, all of that, what exactly happened, I don't know. But I do know that people were like hypersensitive to all kinds of IP things because they were kind of worried about the university administration. And the rules did not get changed. After having tried to pull this stunt, there was like no way that they could change it. So in the computer science department, there were a couple of things that came out that the people got kind of hyper about. One was a thing called Scribe, which I dearly love. Scribe was kind of like, well, it predated tech, but it was kind of like tech in that it was a notation for writing printed documents that would come out beautiful. And it was really, really nicely done. It was the PhD thesis of a guy named Brian Reed. And then there was the thing that I did, namely Emacs. When I did the port of the ETH Pascal to Multics, I got to learn Emacs on Multics because that had become kind of the most common editor on Multics was Emacs. Of course, this was not the same as the PDP-10 Emacs that the folks at MIT did. But then I get to grad school, and I'm like, damn, VI sucks. Well, it's true, right? And at the time I was using Unix all the time, and at about that time it was mostly V7 Unix from Bell Labs. But over time, we sort of migrated to using BSD as the Berkeley folks started to get stuff that was actually running. And so Emacs got pretty popular. I started I started sending mag tapes all over the place because this was the early days of the ARPANET. And the high-speed, dedicated point-to-point links that went across the country were all 50 kilobits per second. They were the most expensive, highest-speed links ever. And if you've got like a big piece of source code or a binary or something, a mag tape and US mail will beat the network every time. It's not that way anymore, thank God. But because of the whole Godspell thing, I had all these, I was like really, I was really open to sharing this stuff. I just didn't want to be abused. And it got, that sort of got heightened for me when I got contacted by some folks who were founding a new company that did mini computers, and they wanted to put Emacs on it, and they wanted to make like Emacs be like the command front end for it, which is a little bizarre, but their letter was almost literally, you'll get famous and we'll get rich. And I was sort of like, if you guys are planning to get rich off of this thing, at least give me a cut. Because, I was a grad student, right? Anyway, I was like really careful about it. And at one point, it became clear that I either had to find somebody else to maintain Emacs, or I could graduate. I couldn't do both. So I went around the internet trying to find somebody who would take over the maintenance of Emacs so that I'd have enough time to graduate. And I couldn't find anybody, right? Everybody, they always had a day job. And I found, you know, what were literally two guys and a dog in a garage in New Jersey who were willing to take it over, but they had to pay the rent. So I said, you know, you could charge, okay, here, take it, you can charge commercial customers, but universities have to get it for free. And they were happy with that. And then certain people like exploded, and mostly it was, strangely enough, IBM and DEC. They started behaving strangely. The two guys in the garage actually hired some lawyers. It turned into a big court case. The two guys in the garage actually won, but it was kind of a Pyrrhic victory. And it was just freaking messy. And even though I was trying to run it kind of like open source, I mean, the concept wasn't there, trying to stop people from really abusing kindness, like that one letter or the stunts that DEC and IBM were pulling. They really, really ticked me off. And you know, that sort of has played out. But sometimes, you know, when you do things like one of the pieces of work that I did as I was doing sort of experiments to lead up to my PhD thesis was I built a spreadsheet calculator. And if you do a Google search and you type in man SC, you'll get the man page for SC, or you can look it up on Wikipedia, and this is its Wikipedia page. And it was, you know, just an experiment that I did to try to understand why the evaluation rules in VisiCalc were so stupid. And they didn't need to be that stupid. It was because they were just like top to bottom, left to right. And they didn't need to be. They could be dependency directed. And I did these like dependency directed algorithms, and it's like, this wasn't hard. And it was a spreadsheet calculator that worked on text terminals. And it's still there. You can still get it. I'm listed as the original author. And I built it in about 1980. The latest release is in 2018, version 7.16. And you know, it's like 40 years later, this thing is still kicking. And it was something that I spent a week on and threw over the wall and said, if you want to have fun, go have fun. And that's one of the things that I find really lovely about open source is that, you know, often when people just throw things over the wall, they get abandoned and they just like sink away. And sometimes they acquire a life. And, you know, it just depends on who finds them to be valuable. And then I eventually ended up working at Sun. And in many ways, Sun was built on open source, although getting the corporate lawyers happy with the whole concept was difficult. The Sun OS and Solaris were all based on BSD. The original engineering staff at Sun was all basically hippie weirdo freaks. And there was like way too much tie-dye in the halls. And so we used BSD, but we used BSD kind of inbound, you know, getting the lawyers happy with releasing stuff under similar terms was really hard. There was a utility called Indent that I believe was the first piece of software that Sun contributed to that it was possible to get the lawyers happy with redistributing it. And this was something that had originally come from a university whose name I forget. But now, if you type, man indent, you'll still find it, including evidence of a pissing fight that I had with a guy named Bill Shannon. It's still in there, right? It says, Bill Shannon. It's this particular way that he wanted to put blanks always after size of. So even if you parenthesize the parameter after size of, he still wanted there to be a blank between size of and the parentheses, but not do functions that way. So that if you typed size of in a syntax that was reminiscent of a function, he didn't want it formatted like a function. So he wanted a blank before size of. And so I called it the Bill Shannon option or the BS option. And no disrespect to Bill, he is one of my favorite people in the world, but he has, and even though it's been like half a forever since then, I was kind of amazed to find that little food fight lives on. So Java, that was a pretty rocky road. And it was a pretty difficult road from the point of view of the sort of open source aspects. Because the very first day we released Java, we released it with all the sources. But the license was kind of complex and messy. And it was sort of, and I wasn't involved in that first license at all. It was sort of an attempt to get some kind of fairness because things were getting kind of out of hand, actually a lot out of hand. And one of the things that we kept running into was this notion of, freedom is a balance. Freedoms often collide, and you find instances of this all over the place, right? One of the simplest is the agreement that we'll all limit, our freedom of what side of the road to drive on in order to gain some freedom to live without fear, right? I mean, what would the world be like if there wasn't a rule that says thou must drive on the left side of the road, the right side of the road, depending on where you are? And so yes, you end up with restrictions on your freedom, but everybody lives. And one of the things we were particularly worried about was that there were kind of two camps of people. There were developers, and there were, let's call them platform providers. They were the people like Microsoft and IBM and HP and Apollo and DEC and Apple and all of these folks. And they wanted the ability to differentiate. But they would say differentiate in a way that made it sound like a good thing. But in actual fact, what people really wanted was ways to make things sticky. They wanted to be able to treat Java the way they treated SQL. Right? So if any of you have used SQL extensively on commercial databases, they always have extensions and weirdness. And so if you've got some app that's been written to use the SQL on an Oracle database, the chances that you can lift that up and drop it down on top of MySQL or Postgres or something like that is pretty limited. And from a developer's point of view, that sucks. From a platform provider's point of view, that's exactly perfect. So we were trying to balance, platform providers' ability to differentiate with developers' right to expect their code to run. And there was a big marketing campaign that I don't think Microsoft literally called it this, but their mantra was embrace and extend, which various people translated to things like deface and distend. because they got a little weird and got sued and lost some court cases and yada yada. And so, one of the things that was hard at the time was, how do you come up with rules that control bullies that don't annoy everybody else? And it's really, really hard. The Java community process was an attempt to do that. I think it was middling successful. It was hard to get as much community involvement as we would have liked, just because the commercial involvement was so heavy. And coming up with these rules was just crazy. Like in the very first iteration of the JCP, one of the rules was that all decisions had to have a paper trail or an email trail that could be audited so that you could discover why a decision went one way or the other. And a bunch of the big players wanted that to be in there so that they could know that they weren't being bullied. I mean, it's sort of weird to think of companies like IBM worried about being bullied. But within like a year, that rule got cut because they all love backroom deals. And it was just really, really hard to figure out, how to do that. But eventually we got to GPL, and this was partly it was partly a major leap of faith from lots of people at Sun. And one of the things that was kind of surprising to folks was it wasn't a financial disaster. The whole, revenue from service and support works, but it particularly works if you're a large trusted organization. And a lot of companies in the open source world try to earn revenue off of service and support, and often one of the biggest problems is, they'll have these big enterprise customers, and the customers will say, well, how can I trust you? Will you be around in 5 years to support this thing that we're depending on? And one of the things that we found out as kind of a piece of the math of the system is that the marketing leverage that we got by having such broad access was greater than any license revenue we could ever have made. And the other big thing that happened was that the sort of forking and distending Java became, because it had become such a big thing, it was being really controlled by the community. When people started to get out of line, the community would bitch and moan. And we were far less effective at controlling various folks than the community was. And just kind of letting the community have their influence was almost always the right answer. And one of the nice things about the open sourcing of Java was that it led to the open sourcing of essentially everything else. Sun GPL'd almost everything, with one really noticeable exception, and that was Solaris. They kind of open source with a kind of open source license that had a variety of problems. And really it was mostly a people problem inside the teams. They did get close, and they were making progress. If they had had like another year or so, the Solaris was experiencing continued adoption and growing adoption. Definitely making progress, and the teams were making progress emotionally getting with the whole thing. But then there was a change in ownership. It's Oracle. Need I say more? but the Java community, empowered by the license, empowered by the OpenJDK, empowered by kind of Oracle's really fear of the community, kept the beast at bay. And Java survived nicely. It's doing well. I'm astonished. But Solaris, tragically, and I deeply loved Solaris, Oracle was able to kind of claw back the license, and they made it be a something that was a direct revenue generator, with prices that were just freaking absurd. And so I eventually had to turn off my last Solaris machine at home. Everybody that I know who had Solaris machines at home, Solaris made a really, really wonderful RAID array manager. ZFS is phenomenal. But it was a total crash and burn. So what do I love about Apache? Why did I come here? I guess my number one thing is the Apache license. It's like the lowest religion license. That's really, really clean. It's got a phenomenally strong community. And the community isn't just the committers, the people who are parts of the Apache Foundation, but all of the people who use it. And one of the really important distinguishing things about Apache for me is that they have a real code of conduct. Every now and then people kind of turn into bullies and they get swatted. And in some of the other communities, people get kind of out of hand, and there often aren't the same kind of rules that Apache has. And Apache's rules, if you look through like all the rules of what you have to go through to become a committer, the kind of agreements you have to sign, they're pretty strict. But really, they're there to stop people from all kinds of abusive games. And of course, they let me be a committer. I haven't committed very much, actually, very close to zero. But I do an awful lot of testing and random other things for the NetBeans project. I'm a big supporter of Apache NetBeans, and having watched the whole progress through the joining Apache, going through the incubation process, and then graduating to be a top-level project, that I thought was fabulous. The Apache team has done such a wonderful job, and thanks to everybody who was involved in that. And not only in that one particularly, but in coming up with the code of conduct around that. So thanks. These days I work at Amazon. Apache is our default license for all of our open source projects. Thank you.